Hi guys, today we are going to be talking about exponents, and as the title suggests, we're going to be looking at more specifically their rules. But before, let's go ahead quickly review what's so special about an exponent. So I know that you know that the exponent tells you how many times the base is used as a factor. So in this case, the superscript, that's our exponent. I don't know how to spell exponent. And in this case, our base is 2. Okay, so in this case, sorry. Okay. So the exponent tells us how many times the base is used as a factor. So if the exponent is 4 and the base is 2, that means that we have 4 factors of the base of 2. So that will give us 2 times 2. How many times? Yep, 4 times. And then with some magic, that gives you 16. Cool. Now, am I going to give you this problem on the test? Of course not, because this is an algebra course. Alright, so we need to toss in like an X in there. So we're gonna go, this is how it's gonna go down. Instead of me giving you the rule right away, I'm gonna just do some fun problems and then we'll introduce the rule. Okay, all right, cool. So problem A, let's go ahead and write it together. So we have, what do we have? We have x squared times x cubed. X squared times x cubed. So it's like, oh, Miss Torres, how are we gonna handle this if we don't want to tell us the rule? I want to tell you that you don't really need a rule. Okay, the rules will make your life a lot easier, but if worse comes to worse, you're gonna use your fingers. Okay, so this is how it's gonna go down. So let's just pretend that we wanted to talk to our preschooler and we're like, okay, what does x squared mean? We're like, okay, the base is x, the exponent is 2, so that means that we have 2 factors of the base, namely x. So we have a x times x, and what's going on with those x's? We are going to multiply them by, you guessed it, 3 more x's. Okay, so x to the third means that we have 3 factors of that base. So we have x times x times x. Okay, and what is going on? We're just multiplying a bunch of x's. Okay, so what do we do? How can we rewrite it? Okay, since we have pretty much a product of 5 factors of x using exponents, we're gonna write it as x to the 5th power. Okay, if you backtrack yourself, what does x to the 5th power mean? Well, that means you have product of 5 factors of x. Oh, I don't know how to count. Okay, 5. Okay, 1 2 3 4 5. So it's like, oh, this is great, Miss Torres. Is we don't need a rule. Yeah, we don't need a rule, but you know what, sometimes numbers will get spicier, so we'll need a rule. Okay, problem B. How many are we gonna do? A bunch. This is why we're gonna spread this video into spread this unit in 2 videos. The first video is all the rules, and the second video, spicy problems. Okay, well, spicier. Okay, problem B, we have x squared times x to the 4th. Okay, so without a rule, we have 2 factors of x multiplied by 4 more factors of x. So pretty much we have product of a bunch of x's, 1 2 3 4 5 6 to be exact. So we're gonna tell the world that x squared times x to the 4th will give us x to the 6th. Oh, Miss Torres, we're tired. I know, but you know what? If we do 3 problems, the keep your cool way, meaning without a rule, and if you're like, this is a little bit tedious, then maybe you will be more inclined to remember the rule. All right, break it down to your preschooler. Okay, x squared, it means we have 2 factors of the x. Not preschooler, your preschool friend. Yeah, that's how I speak. X to the 5th means we have 5 factors of x. Okay, 1 2 3 4 5. Okay, so overall we're multiplying a bunch of x's just like we had in the original problem, and we have a grand total of 1 2 3 4 5 6 7. Okay, so we have x to the 7th power. Okay, we're gonna stop right here and then get to our rule. Okay, but let's look at our problems and solutions. X squared times x cubed gives us x to the 5th. Okay, let's look at the exponent. 2 plus 3, 5. X squared times x to the 4th gives us x to the 6th. Can we add the exponents? Yeah. 2 plus 4, 6. X squared times x to the 5th. It's like, oh crap. Let's go ahead, add the exponents. 2 plus 5. Oh, I'm crying. Tears of happiness. Okay, so the moral of the story is this: if you are multiplying 2 things that have the same base, you are going to keep the base and then what to the exponents? Yeah, you're gonna add the exponents. So let's go ahead and introduce our first rule. Okay, product rule for exponents. Okay, why do we call it product rule for exponents? Well, because it's a rule for exponents when we have multiplication. Okay, so to be more specific, it's when you're multiplying two things that have the same base. So the product rule for exponents says this: if you have a factor, if you have some factor and it's raised to the nth power, and you're multiplying it by another factor that has the same base, how are you gonna handle it? Okay, you're gonna keep the base and add the exponents. So let me just put a little love note: add exponents. Okay, so in short version, if you're multiplying two things that have the same base, you're going to keep the base and add the exponents. Miss Torres, do we have to remember this? You know what? You don't have to break it down. Pretend you're talking to your preschooler and you're good. Okay? But of course, if the the exponent of 5 was already pretty spicy. Imagine if we had x to the 20th. No. Well, remember the rule. Okay? So let's go ahead do two problems using this using our new rule. Okay? So let me go ahead write simplify. Okay, the directions, the long directions, you read simplify the expression, answer should contain positive exponents. Okay, the reason why we have this disclaimer right here, answer should contain positive exponents only, or positive exponents, is because it would be nice if we lived in a nice world, okay, in a peachy world. No, I'm just kidding. Okay, so we just need to write our answers with positive exponents. So what if you have a negative exponent in your answer? Then fix it. Okay, make it positive and you're good. Okay, so let's go ahead do a problem. Problem A, same one. Okay, x squared times x cubed. Okay, so you could break it down like if you're talking to your preschool friend, or you can use your newfound rule. Okay, we are multiplying two things that have the same base. Multiplying two things that have the same base, bust out the product rule for exponents. You're going to keep the base and add the exponents. So of course, I know that you can add in your head. I know that you can add 2 and 3 in your head, but these are our notes. Okay, so we want to write down our thought process on paper. But if you want to go straight to answer, go for it. Problem B. Problem B, we have x to the 5th times x to the negative 3rd. Now, am I having a moment? Of course I am, because that negative number scares me. But if you're cool with problem A, you're cool with any problem that I toss your way. I kid you not. So what is going on? We are multiplying two things that, you guessed it, have the same base. So how are we going to handle it? We are going to keep the base and add the exponents. Okay, product rule for exponents: keep base and add the exponents. Sum of the exponents will give us 2. So moral of the story is that x to the 5th times x to the negative 3rd will give us x squared. Fantastic. So let's go ahead introduce another rule. Okay, where do I have space? I'm trying to save paper, but I don't think I can. Okay, so we have negative exponent rule. Okay, negative exponent rule. This one I would really like to break it down for you, like if we were talking to our preschool friend, but I don't have like a nice way to talk to our preschool friend, so I'm just gonna tell you the rule. Okay, so the negative exponent rule, I am so thankful we have it. Why? Because the rules say simplify and make sure that your answers have positive exponents. So there's going to be a time where we may have a negative exponent in our answer, so we need to know how to fix it. Okay, so I'm going to write it out. Okay, so if we have a factor that's being raised to a negative power, by some miracle, this is the answer. Okay, so it was like in the top, and then we bring, oh, I lied to you. Okay. I should just restart this video. Oh no, but it's too late right now. Okay, so if we have a factor that's being raised to a negative power, how are we gonna fix it so it's positive? Pretty much you're gonna bring the factor down, and then you're gonna make the exponent positive. Okay, what is going on? Okay, so this is pretty much what's going on. we have a, oh, I don't want to write on my paper. Oh, it's okay. You know what? I'll do it right here. Okay. Let's just say we had x to the negative first power. And then we wanted to make the exponent positive. So what are we going to do? We're just going to move it to the other side. Other side of where? The fraction bar. So I'm going to put a fraction bar. I'm going to put a 1. And then to make the exponent positive, just bring it to the other side. And then when you do, I'm so embarrassed. My special effects didn't work out. This is what you get when you buy glue from the dollar store. Okay, scratch that. I'm so sad. If you could see my face, I'm crying. No, I'm not. Okay, cool. So pretty much what I want to get out is this. If you have a factor and it's being raised to a negative power, to make the exponent positive, you're going to move the factor to the other side of the fraction bar. So pretty much we take the reciprocal. Okay, so this is how it's written in the books, but let me write the word or. Okay, so what if your factor is in the bottom of a fraction? What if your factor that's being raised to a negative power is in the bottom of the fraction? It's okay. What did I say before? To make the exponent positive, move the factor to the other side. Well, you can read my mind. Move the factor to the other side of the fraction bar. So in this case, we're in the bottom, so we come to the top. And then we switch out the exponent to make it positive. So when we switch sides, we make the exponent positive. Why do we bring it up? Because pretty much we're taking the reciprocal. You know, the reciprocal of x is 1 over x, and then 1 over x by some miracle simplifies to x. But this is like so much work for me. So just remember, if you have a factor that's being raised to a negative power, whether we're like, this is not a fraction, but pretend it is, whether the factor is in the numerator or the factor is in the denominator, to make the exponent positive, you're going to move the factor to the other side of the fraction bar. So if you're in the top, we're switching sides to the bottom. If you're in the bottom, you're switching sides to the top. Okay, so let's go ahead and do some quick problems illustrating our negative exponent rule. I was thinking about using my special effects for like the division problem. I'm crying now, so no. Didn't work out. Imagine if my boss watches this video. Ay, Dios mío. Alright, so let's go ahead and simplify. Oh, you know, because there's no directions. I just assume that you can read my mind. Okay, so problem A, we have x to the negative 4th power. So it's like, well, what is there to simplify? Okay, so when it comes to expressions and we're asked to simplify, you know, you're gonna like add, subtract, multiply, divide, clear fractions, and then if you have a negative power, fix it so the exponent is positive. So the question is, how are we gonna handle it? So remember what I told you. If we have a factor, no matter where we're at, and we're being raised to a negative power, to make the exponent positive, you're gonna move the factor to the other side of the fraction bar. What if we don't have a fraction bar? Then make one up. Okay, insert your special effect 1, and then just like that, it's like, okay, cool, we got a fraction bar. So we're going to move the factor to the other side of the fraction bar. So in this case, bring it down. We switch out the exponent. It's going to look kind of weird if we put blank over x to the 4th. So let's go ahead and put a 1 in its place. Fantastic. Problem B. I'm still trying to get over my yeah. Okay, so we have 1 over x to the negative 5th. Okay, so we're asked to simplify. Okay, simplify the expression. So in this case, my issue is that we have a negative exponent, and when it comes to like expressions, we don't want to have negative exponents. So to make the exponent positive, we're going to move the factor about the other side of the fraction bar. So in this case, we're going to come up. Okay, so that will give us, we bring the x up, we switch out the exponent. What about this times 1? Well, x to the 5th times 1 is still x to the 5th, so we'll leave it as such. Cool. How about 2 more? All right, cool. I got you. All right, problem C. We have negative 4 x to the negative 3rd over 15. Okay, something that I want to point out is this. It's okay if our answers are negative. It's just the exponents that we don't want to be negative. So In this case, I have no issue with -4. Why not? Well, because -4 is not being raised to a negative power, so that's not going anywhere. My issue is with this x, okay? I don't want negative exponents, okay? So to make the exponent positive, you're going to move the factor. I said it before, move it to the other side. If you want me to use my real math words, then take the reciprocal. But moving it to the other side is just easier for me, okay? For me to say. Okay, so in this case, the -4 stays put, the 15 stays put, the x is the one we have issue with, so adios, bring it to the other side. And anytime you move a factor to the other side, then we can switch out the exponent. Okay, all our exponents are positive, so we're good. So remember, negative answers are okay, negative exponents are not. Okay, one more problem to knock out this set. Okay, problem D. Problem D, where am I? Okay, so we have 2, I'm out of space, okay. We have 2 over 3 times x raised to the -2nd power, okay. So in this case, excuse me, my issue is that we have a negative exponent. So what are we gonna do? Negative exponent rule. If we have a factor raised to a negative power, to make the exponent positive, you're gonna move the factor to the other side of the fraction bar. So in this case, we bring it up. So let's go ahead, write down whatever stays put. 2 is on top, 3 is on bottom, and the x has to go. We bring it to the top, and then we safely switch out the exponent. Fantastic. What? We should do 10 more? Shh, you read my mind. Okay. Alright, so let's go ahead, switch up the direction slightly. We're gonna put evaluate. Okay. Evaluate. Alright. And these I will want you to answer by hand. That would be nice. Problem A is 3 to the -3rd power. So I'm gonna tell you what the answer is not. Okay, the popular answer is -27. Okay, but I said I'm gonna tell you what the answer is not. Okay, so if you got that, let's go ahead explain why that's not it. Now, if the problem was just 3 to the 3rd, it's like, oh, I'm a genius. 27. Okay, but I don't know how to evaluate when we have a negative power. So what am I gonna do? I'm gonna fix it so it has a positive power. So let's go ahead and apply the negative exponent rule. Okay, so we're gonna insert a fraction bar, because if we don't have a fraction bar, then make one up. Then what are we gonna do to make the exponent positive? We're gonna move the base to the other side of the fraction bar. So in this case, we're gonna bring it down. So that will give us 3. We moved it in place. We moved it to the other side so we can switch out the exponent. So that will leave us with 1 over 3 cubed. Last time I checked, 3 to the 3rd power is 27. So the moral of this story is that 3 to the -3rd power is not -27, but it's actually a 27, or 1 over 27. Problem B. How many are we doing? 3, just 3. Okay. So we have 1 over 12 to the -2nd power. Okay, so the popular answer, not the popular, but a popular student mistake is -1 over 44. Okay, but that is incorrect. So what do they say? No bueno. All right. I genuinely don't know how to evaluate this. I really don't. Why? Because the negative exponent throws me off. If the exponent was positive, bam, okay? So let's go ahead and make the exponent positive. So to make the exponent positive, we're gonna move the factor to the other side. So in this case, bring it up. So that will give us 12. We'll switch out the exponent. Last time I checked, 12 squared, the square root of 12 is 144. So we don't need a calculator, just a free-handed. For the grand finale, not of the day, but of these problems, okay? So we have -5 over 2 to the -3rd power. Fantastic. So first things first, before we can divide these two, let's go ahead and fix it so this exponent is positive. To make the exponent positive, we're going to move this 2 to the other side of the fraction bar. Why? Because that's how we handle it. Negative exponent rule, You want to make the exponent positive, move the factor to the other side, okay? So we have a -5 in the numerator. Guess what? It's going to have a neighbor, okay? We're going to multiply it by this 2 that's coming up, and then we'll switch out the exponent. 2 to the 3rd power, punch it in for me, because I think it's 8. And that will leave us with -40. Fantastic. What? We want more rules? Oh, I thought you never asked. Okay. The next one, I'm just gonna tell you the rule because there's I don't have like a nice model for it, or I don't have a nice preschool explanation. Okay, so I'm just gonna tell you. 0 exponent rule. 0 exponent rule. Okay, so what the 0 exponent rule says or is, it's a rule where the exponent is 0. That's a pretty neat name, huh? Okay. What the 0 exponent rule says is this: for any non-zero number, so let me just put a little love note, x cannot equal 0. For any non-zero number, if you raise it to the 0 power, that would always simplify to 1. Okay, why? I mean, I could show you, but I don't think you want this video longer, okay? So just keep that in the back of your mind. Now, this only holds true if the base is not 0. What if the base was 0? So let's put a little disclaimer. Note, pretend you can read that. Note, 0 raised to the 0 power is not defined. Okay, that's it. But for our course, I'm not going to give you this, okay? But that is the rule. Okay, so let's go ahead and evaluate a couple of problems, literally, okay? So we want to evaluate problem A. We have 35 raised to the 0 power. Now, if I try to break it down for myself, like if it was 2 to the 3rd power, you know, 2 to the 3rd power, it's like, oh, it's 8, you know, because it means we have 2 times 2 times 2, okay, 3 factors of 2. But 35 to the 0 power, if I try to talk to myself, I'm like, oh, that means we have 0 factors of 35. That doesn't really make sense, okay? So I'm just going to accept the rule, okay? And if I'm really interested why it works, then we stay after class, okay? So we have an exponent that's 0. How are we going to handle it? Oh, exponent that's 0, 0 exponent rule, okay? For any factor that's not 0, when you raise it to the 0 power, that will always simplify to 1, okay? Problem B, which will be the end of this round. What if we have negative 1.3 raised to the 0 power? Okay, what is going on? We have some factor that's being raised to the 0 power. It doesn't matter what the base is. If you raise it to the 0 power, the answer is always 1. Positive 1. Okay, never negative 1. Cool. Let's go ahead and introduce our almost last rule, quotient rule for exponents. So in my head, I had like a really nice special effects, but you know what happened when I flipped this. This one's working, but I'm not gonna get into it. Okay. Quotient rule for exponents. I left my laminated ones in the class, but I don't want to go drive over there. I don't want to drive to school. Alright, so the quotient rule for exponents. Okay, how does that go? Actually, I wasn't going to give you the rule right now. Simplify, okay? We're going to build it up. Oh, Miss Doris, I already wrote it down. Well, you can erase it or cross it out, okay? The reason why we're gonna do it like if we're talking to our preschool friend, is because I want you to have an alternative. Like, rules are good, but only if you remember them, okay? And if you can't remember them, then you keep your cool and you break it down. Okay, so problem A. So we have 5 over 15. Oh, Miss Doris, this one's gonna be on the test. Actually, it's not, okay? But if you can do this problem, then you can do any division problem. Now, 5 over 15, and the directions just be simplified. It's like, okay, we have a fraction. You want me to simplify it? I guess that's code for let's reduce it. So let's go ahead and reduce it. The numerator and denominator have a common factor of 5. So let's do this. 5 goes into itself once and into 15 3 times. Okay, we got a 1 on top, 3 on bottom, so we're good. Okay, so the answer is just 1/3. Now, whatever you did for problem A, I need you to have this in the back of your mind for the rest of the division problems. Okay, problem B. So we have x to the 5th over x to the 3rd. Okay, so we are not multiplying two things that have the same base, so no product rule here. Okay, we have a division problem, and the question is, how are we going to handle it if we don't have the rule introduced just yet? Let's just pretend that we're talking to our preschool friend. Okay, so pretty much write it without the exponents. So in the numerator, if we have x to the 5th, that means that we have 5 factors of x, or 5 factors of the base. So 1, 2, 3, 4, 5. What's going on with those 5 x's? We're dividing them by 3 factors of x. So 1, 2, 3. Okay, what are we gonna do now? Cross cancel. Okay, x on top, x on bottom, they cancel. But notice how like my lines, my cancel lines, cross cancel lines blend in. So I'm gonna circle out, circle out. We have another pair of x's that we can cancel out. So let's do this. We have another pair of x's that we can cancel out. And then we're just gonna write down what we're left with. Okay, what do we have? In the numerator, we have 2 factors of x. Okay, so that will give us x squared. Okay, so the moral of the story is that x to the 5th divided by x to the 3rd gives us x squared. Fantastic. For the grand finale of this round, before I give you the rule, okay, so we have x squared over x to the 6th. Okay, we're gonna pretend like we're talking to our preschool friend. Okay, so in the numerator we have x squared, so without the exponents means we have 2 factors of the base. So we have 1, 2. What's going on? We're dividing it by 6 factors of x. So 1, 2, 3, 4, 5, 6. This is a really tedious way to do it, but if you forget the rule, then just do a quick example. Okay, so cross cancel whatever you can. So we got like a pair of x's that a set of x's that we can cancel out. We have another set of x's that we can cancel out, and in the bottom we're just left with 4 factors of x. Okay, so we have x to the 4th in the denominator and a 1 in the numerator. If I had put 1s over here when we cross cancel, maybe that would have been nicer, but I forgot. Fantastic. So now let's go ahead actually introduce our quotient rule for exponents. Why is it called quotient rule for exponents? It's called quotient rule for exponents because it's a rule like when you have a quotient or division problem, and the question is, what are we going to do with the exponents? Yeah, that's how I broke it down. Cool. Let's go ahead, write out quotient rule for exponents. Okay, dust, sorry. All right, quotient rule for exponents. Quotient rule for exponents. Okay, so I'm gonna write it for you. Yeah, it's too much space, sorry. I'm gonna write it down for you how it's in the books. Okay, so we have x to the m over x to the n. So you're dividing two things that have the same base, and by some miracle that gives us m minus n. Okay, so what did we do? We were dividing two things that have the same base. How are we gonna handle it? We're gonna keep the base and subtract the exponents. So let's go ahead and put that love note. Subtract the exponents. Okay, this is how you're gonna see it in every book. Okay, but I'm gonna give you a different way of writing it. To tell the truth, I don't remember how to write the rule. I just remember how it's done. Subtract the exponents. What if I give you the same problem? So we are still dividing two things that have the same base, but then I say your answer is 1 over x to the n minus m. Now, am I expecting for you to remember, hey guys, if you have x to the m over x to the n, the answer is x to the m minus n, or if you have x to the m over x to the n, the answer is 1 over x to the n minus m? Of course not. Hopefully I said it right. I don't remember that, okay? But what I want to point out is this, that if you're dividing two things that have the same base, you're going to keep the base and subtract the exponents. The question is, which exponent should we subtract? Okay, in the first one, I guess we subtracted the bottom one. In the second one, we subtracted the top one. Depending on which one we subtract, that will determine where we'll keep the x, like if it's in the top or in the bottom. Okay, I'm gonna illustrate this with examples. Okay, so quotient rule for exponents, how are we gonna handle it? We're gonna keep the base and subtract the exponents. But let's go ahead, update this. Subtract the smaller exponent. Okay, let's go ahead, cross this out. It's not that it's incorrect, but that's in my way. Okay, the reason why I say subtract the smaller exponent is it's because if you subtract the smaller exponent, then you will avoid having negative exponents in your solution, so that will save you a step. Okay, so let me go ahead, box this. Okay, so let's go ahead, write down a set of problems. So we're going to go ahead, write simplify. Fantastic. Am I recording? Yeah. Okay, because I'll start crying if I wasn't. Okay. So what was I? Okay, problem A. I'm going to throw in a curveball. Okay, so we have x to the 5th times x to the 3rd. It's like, why do we have this problem here? I thought we were going to do stuff for like quotients. Yeah, we are in a bit. Okay, so let's go ahead, review. What's going on? We are multiplying two things that have the same base. So if we're multiplying two things that have the same base, we're going to keep the base and add the exponents. Okay, so that was a quick review. Okay, let's go ahead, do another problem. Am I going to do it? No, okay. Problem B. Okay, we have x to the 5th over x to the 3rd. Okay, so we have a division problem. Okay, if we're dividing two things that have the same base, we're going to use the quotient rule for exponents. Okay, we're going to keep the base and subtract the exponents. But to be more specific, we're going to subtract the smaller exponent. Last time I checked, a 3 is smaller than 5, so we're going to subtract 3. Okay, so pretty much we're dividing top and bottom by x to the 3rd. Okay, x to the 3rd goes into itself once, and in x to the 5th, I don't know, we got to subtract that smaller exponent. So I'm going to go ahead, write minus 3. 5 minus 3 is 2. So the moral of this story is that x cubed goes into x to the 5th, x to the 5 minus 3 times, or x squared times. Okay, so write down what you have. What do you have? You have an x squared on top and a 1 in the bottom. But there's really no need to write that 1. Okay, so we're going to simplify it as x squared. Okay, problem C. Where am I? Actually, no. I'm debating if I should do C, if I should do my silly memory aid. I've lost the flow, so let me go ahead, write down problem C. Okay, problem C, where am I? So we have 5 over 15. Okay, oh, why are we doing this problem again? Because I want to make a point. Okay, when I ask you to simplify this problem without skipping a beat, you're like, oh, it's a 3rd. Okay, I don't think you think twice about how do we know where the 3 goes? Is it in the top or is it in the bottom? The math tells you. Okay, so like we divide by 5, 5 goes into 5 once. Okay, the original 5 is on top. 5 goes into 15 3 times. Okay, so we're gonna put it in the bottom. Okay, when you're dividing two things that have the same base or applying the quotient rule, I don't want you to ask yourself, where does the x go? Let the math speak for itself. Wherever you're dividing into or whatever, just bring it down. Okay, problem D. Okay, problem D, we have x squared over x to the 6th Okay, fantastic. So it's like we're dividing two things that have the same base. And then I'm like, oh man, with so many rules, I forget. Am I supposed to add the exponent? Am I supposed to subtract the exponent? All these silly exponent rules, they make me so mad. But we're going to pretend we have bad English. So I'm going to say, oh, silly exponent rules. They make me so mad. Why did I write down my frustration? Oh, because someone told me that you should write your feelings. So we're writing our feelings. So what does my frustration have to do with the exponent rules? A lot. Okay, so if we have a multiplication problem, if we have a multiplication problem, we're going to keep the base and add the exponents. However, if we have a division problem, such as what we have right here, if we have a division problem, we're going to keep the base and subtract the exponents. Okay, so is it silly? Yeah, but that's how you remember it. Okay, so when you're like, if you're like, ah, man, like I don't want to do this, I'm just gonna do the rule, it's fine. Okay, this is just a way to remember the rule. If you have a multiplication problem, keep the base and add the exponents. If you have a division problem, keep the base and subtract the exponents. So as you're taking your quiz or test and you're like, ah, I forgot the rule, vent out your frustration. I'm so mad. Okay, cool. Problem D, we have a division problem, so we're going to keep the base and subtract the exponents. Now, something that I want to point out is this. You don't have to worry about like, oh, should I subtract the 2? Should I subtract the 6? You'll get the same answer. The worst thing that will happen is that it'll take you an extra step. Okay, but if you want to save a step, you're going to keep the base and subtract the smaller exponent. So in this case, we're going to subtract the 2 because pretty much we're dividing by x squared. Okay, x squared goes into itself once. X squared goes into x to the 6. I don't know, but we're gonna subtract the exponent. So minus 2, and that will leave us with 4 factors of x. Look at what you wrote and then just copy them down. In the numerator we have a 1. In the denominator we have x to the 4th. Cool. So that's it. So let's go ahead and do another problem. E. So we have x to the negative second power over x to the 4th. Cool. Alright, so in this case, am I afraid of the negative exponent? Maybe, okay, but what's going on? We have a division problem and we're dividing two things that have the same base. So it's like, silly exponent rules, they make me so mad, okay? So if we have a division problem, we're going to keep the base and subtract the exponents. To save time, we will subtract the smaller exponent, namely negative 2. So x to the negative second goes into itself once. And then to the bottom, I don't know, but we'll subtract that exponent. Now, I understand that this will turn into an addition problem, but bear in mind that the main operation was subtraction. So we subtracted. Cool. Difference of 4 and negative 2 is 6. So that will leave us with 1 on top and 6 factors of x in the bottom. Oh, Miss Torres, this is such a long video. Yeah, because I thought it was going to be beneficial for you if we had all the rules together. But you could take a break and come back if needed. Problem F, which is the last one of this round. Where am I? X squared over x to the negative third. Okay, so what's going on? We're dividing two things that have the same base. So it's like, I'm going to vent out my frustration. If I have a division problem, I'm going to keep the base and subtract the exponent. The smaller exponent is negative 3, so let's do this. X to the negative third goes into itself once, and into x squared, we're going to subtract that exponent. So minus negative 3, and in turn that difference will give us 5. It's not a guessing game of what the x goes. Just copy down your work. Okay, in the top we have x to the 5th. And there's no need to write down the 1 because x to the 5th over 1 is just x to the 5th. Alright, so what are we going to do next? Give me a sec. Alright, so that was a nice break. So let's do this. So we are asked to simplify. Oh, Miss Torres, is this one going to be on the test? No, okay. But again, if you can do this problem, you can do any problem where you have some power, okay, or exponent. So 2 to the third, you have options. You can just evaluate it, or you can talk to your preschool friend and write 2 times 2 times 2. Do what you gotta do. Fantastic. Problem B. So we have x squared raised to the third power. It's like, oh man, like, well, how am I gonna handle it? I don't know. We're not multiplying two things that have the same base. We're not dividing two things that have the same base. So let's just old school it. Let's pretend like we're talking to our preschool friend. So if the exponent is 3, that means that we have 3 factors of the base. So that means we have an x squared multiplied by an x squared multiplied by another x squared. You could break it down more, or you can use your rule. Okay, so silly exponent rules, they make me so mad. So if we have a multiplication problem, like we're multiplying some things that have the same base, we're going to keep the base and add the exponent. Okay, and the sum of the exponents, namely 2, 2, and 2, that will give us x to the 6. Okay, so the moral of this story is that x squared raised to the third power, that will give us x to the 6. So let's go introduce our almost last rule. Actually, yeah, well, it is technically our last rule, but then we're gonna revisit another one spiced up. Okay, so let me just go ahead, write down power rule for exponents. Let me go ahead and make that plural. Okay, we have the power rules for exponents. Okay, I'm gonna write down 3, but to tell you the truth, you only have to remember the first. That's why I tell my students. Okay, the power rule for exponents goes like this. If you have a factor and you raise it to some power, what is the rule? Think about, how do we get the 6? 2 plus 3, that's not 6. 2 times 3, that is 6. Okay, so the power rule for exponents says this: if you have a factor and you raise it to some power, you're gonna keep the base and multiply the exponents. So let me speak to myself. Multiply the exponents. Okay, so I'm gonna write down 2 more, but they're all an extension of this one. Now, what if we have a product of factors? So x to the m times y to the n, and we raise it to the p power. Well, how are we gonna handle it? We're just gonna apply the power rule to each factor one at a time. First factor raised to some power. What is that power rule? Keep the base and multiply the exponents. Oh look, 3 fingers. All right, so the base is x and the product of the exponents will be m times p. 1 factor down, 1 more to go. Okay, next factor, y to the n raised to the p power. Okay, power rule, keep the base and multiply the exponent, so that will give us np. So again, this just comes from the first one. Now, third case scenario, what if we have a quotient of factors? Oh, not x, y. That looks weird. Okay, what if we have a quotient of factors, so x to the m over y to the n, and we're raising it to some power? Again, if you're cool with the first one, that's the only one you really have to have in the back of your mind. Hopefully it doesn't smear, and it did a little bit. It's okay. If you're cool with the first one, the next 2 should follow. What are we gonna do? We're gonna apply the power rule to the numerator, and then we'll apply the power rule to the denominator. So when we apply it to the numerator, this factor raised to the power rule, keep the base and multiply the exponents. Last time I checked, m times p is just m times p. Apply the power rule to the bottom. Okay, power rule, keep the base, multiply the exponents. Fantastic. Why did I box that? I don't know, maybe because I'm a little tired, but it's okay. Okay, so the only one you have to remember is the first one. The next 2 will follow. Okay, let's go ahead, do 3 problems illustrating each one. When you have a single factor, product of factor, quotient of factors, and you guessed it, they will all be raised to some power. Okay, great. Okay, simplify. Okay. Problem A. We have x to the third raised to the fourth power. I would love to say silly exponent rules, they make me so mad. But unfortunately, we don't have a multiplication problem and we don't have a division problem. So I cannot be mad. I just have to suck it up and remember it. Okay? We're raising power, so power rule. So let me remind myself. If I have a factor and I raise it to some power, I'm going to keep the base and multiply the exponents. Okay, so let's do this. The base is x and the product of the exponents will give you 12. Fantastic. Okay, problem B. We're doing 3 problems to illustrate the power rules, one for each one. Spicier problem, where am I? X squared times y cubed raised to the 5th power. I want to point out what the operation between x and y is. Okay, it's multiplication. So we can do it. Yeah, you cannot see that dot. Okay. The power rule only applies to factors. Okay, whether we have a single factor, product of factor, or quotient of factors. If we have like a plus or minus in there, oh no, we don't distribute. Okay, it's factors only. Okay. So we got 2 factors raised to some power. Let's apply the power rule one at a time. Okay, first factor. We have x squared raised to the 5th power. Power rule. Keep the base. Multiply the exponents. Product of 2 and 5 is 10. 1 factor down, 1 more to go. Next factor. Power rule. This y raised to the 5th power. Well, y cubed. Keep the base. Multiply the exponents. What do we do thereafter? Nothing. Why? Because x and y are different bases. For the grand finale, we're almost done, guys. Trust me. Problem C. Where am I? So we have x to the 8th over y to the 4th, and we're gonna raise that to the 3rd power. So again, if you're cool with the first one, you're going to be cool with any problem involving the power rule. We're just going to apply the power rule to the top, and then we'll apply the power rule to the bottom. Okay, so power rule. Numerator raised to the 3rd power. We're going to keep the base and multiply the exponents. Product of 8 and 3 is 24. Done. Denominator raised to the 3rd power. Keep your base of y and then multiply the exponents. Product of 4 and 3 is 12. Can we keep going? No, because there's nothing to reduce. Okay, so technically we're done, but we're going to revisit a rule with negative exponents, but a spicier version. Okay, so we're going to just call this another negative exponent rule. Another negative exponent rule, and I promise this will be the last one for this video. Okay, we'll knock out the rule and then we'll do one problem done twice. Okay, for your own benefit, not mine. I already passed this class. Okay, so what if you have a quotient, or let's speak in English, what if we have a fraction and you're raising it to a negative power? How are we gonna handle it? Okay, if these were just variables, it's no big deal, but this is very important, like if we had integers. First things first, we want to make the exponent positive. How? If you have a fraction, just take the reciprocal, and then I'll tell you why in a bit. You take the reciprocal, and then now that you took the reciprocal, now you can safely raise the fraction to a positive exponent. Okay, why does it work? Pretty much you're applying the negative exponent rule to the numerator and the denominator at the same time, or simultaneously. Pretend I said that word correctly. I can never say it right, and my students always laugh. It's okay, I already passed this class. When we apply the negative exponent rule to the numerator, remember, when we have a negative exponent, just move it to the other side. So when you apply the negative exponent rule to the numerator and you want to make it positive, bring it to the other side or down. When you apply the negative exponent rule to the denominator, you bring it to the other side, so in this case up. Okay, so this is why the book will say flip it and then switch out this exponent, okay, because you're applying the negative exponent rule to the top and bottom at the same time or simultaneously. I should have Google like say that word for me. Cool. Now that you have a positive exponent, then just keep your cool and do what we did earlier. Apply the power rule to the top and bottom one at a time. Okay, when you apply the power rule to the numerator, keep your base, multiply the exponents. When you apply the power rule to the denominator, keep your base and multiply the exponents. Now, am I going to expect you to remember x to the m over y to the n when we raise it to a negative p power that equals this, which simplifies to that? I mean, you're good, but it's so hard to remember that. Just remember the gist, okay? Power rule, keep the base, multiply the exponents. If we have something funky like this, it's like, oh crap, we're raising it to a negative power. We don't want that. We want a positive power. Okay, let's apply the power rule. Let's apply the negative exponent rule to the top, bring it to the bottom. Let's apply the negative exponent rule to the bottom, bring it to the top, and then handle it. Okay. We were gonna do this problem twice, but I think for length we're just gonna do it once. Let's give the people what they want. Okay. So we have x to the third over y to the second power. Okay, that will give us -7. Okay, we're just gonna do it one way, and if you want to do it a second way, see me after class. So it's like, oh, okay, I am having an issue because we have this fraction that's being raised to a negative power. I really want to raise it to a positive power. So what are we gonna do? We're gonna apply the negative exponent rule to the top and to the bottom at the same time or simultaneously. I'm always gonna say that slowly and incorrect. When we apply the negative exponent rule to the numerator, we gotta bring it down. When we apply the negative exponent rule to the denominator, we bring it to the other side, so bring it up. Now that we apply the negative exponent rule to the top and bottom, now we can safely raise that fraction to a positive exponent. So at this point, we bust out the power rule, the one that we said from the beginning. Power rule, when we apply it to the numerator, we keep the base of y and multiply the exponents. So the product of 2 and 7 is 14. Power rule to the bottom, okay, x to the third raised to the 7th power, we're going to keep the base of x and then multiply the exponents. So that was long. Okay, this unit is always tough because there's so many rules, and it's in your benefit if we do them all in one sitting versus breaking it down in separate videos, or if we were like live, you know, separate lectures. Okay, so we're gonna call this the end. Okay, it is the end of the video. Okay, but in the next video we're gonna do some spicier problems. These were not spicy problems, Miss Torres. Oh, of course they are. They were tough, okay, but they were relatively short because we wanted to illustrate the rule, okay. And in the next vid, we're gonna do we're gonna combine all the rules together, okay. All right, guys, that's my time. Take a break.